All right, so the essential question for today is, how is graphing an inequality, different than graphing an equation? So how is graphing an inequality different than graphing an equation? I'm really going to jump pretty much straight into answering that. When you go to graph an equation and you draw the line that that connects the points, what you're doing is you're saying that each of those points that's on that line is a solution to that equation. So even though the ones that we plot, but also the ones that we disconnect, all of those points there that make up that line, all those billions and billions of points are solutions to that equation. Okay? And so when we graph an inequality, well, inequalities aren't always equal. Right? Some inequalities are just less than, some inequalities are greater than. And so if the inequality is just greater than or just less than, we use a dashed line. So this is akin to when you guys graphed inequalities back in semester 1 and back in Algebra 1, use those open circles on the number line. So it's a dashed line, like it'd be like an open circle. Or like we've been talking about all the domain and range stuff, how it would be like the parentheses on the domain and range versus the brackets. So then conversely, if it's greater than or equal to or less than or equal to, we use a solid line. Because those points are actually solutions to the inequality. They're not just close to the solutions. So this would be like using the closed dot on your number line. This would be like using the bracket on the domain and range. You actually hit that number. Okay? It's actually on the line. So that's the first thing you got to pay attention to, is that are you going to use a dashed line or are you going to use a solid line? The next thing you got to worry about is shading. And so this, again, what this is like when we did the number line stuff, where you would put the circle there, then you would draw an arrow off in one direction or the other. Okay. Well, this is now in 2 dimensions. So you're going to draw your line. You're saying, well, here's some of the answers, but then what about all of the answers that are bigger than that, right? Greater than that. So I would shade all these points out here are also answers to this inequality, because we're looking at 2 dimensions now, not 1 dimension. So we have to shade the graph also, besides just draw the line. So how do we know which direction to shade? Well, with something like, if we just imagine this said x equals -3. What type of line is x equals -3? Sure. All lines are straight. What type of lines? Vertical line. So we'd have a vertical line there, right? But it says that x is greater than -3. So where would greater be? To the right. To the right, yep. So if it says x is greater than, we would shade to the right. And it doesn't matter if it says greater than or equal to. It's just the greater part that matters. Okay? So greater than equal to, you're going to shade to the right if it's an x. Oh, sorry, I meant to write a number there too, sorry. So x is greater than some number, x is greater than or equal to some number, you're going to shade to the right. So conversely, if it says x is less than, or x is less than or equal to some number, well, less than would be off to the left side. So because x lines are vertical lines, shading happens on the left or the right of them. Well, so then y lines, so if it just says y is greater than some number, so if it said y equals 4, what type of line would that be? Y equals 4. Horizontal line, okay. And if I want to say y is greater than that line, I would shade up. Now the other thing that can happen with y is it also could say y is greater than some number times x, right? Like y equals 2/3 x, right? Y is less than 2/3 x. So that line would then be slanted, diagonal. Now if I still want to say it's y is greater than, I would still shade above the line. So no matter what, if it's y is greater than, it's still going to be shading above the line. So if it's y is greater than a number or y is greater than a number times x, they're still going to shade above the line. And then the same way, or conversely, if y is less than some number or y is less than some number times x, we would shade below. It's really going to come down to you guys reading. Okay, y is less than, y is greater than. Okay, greater means above. X is less than. Okay, less is to the left for x. Again, those are for greater thans or greater than or equal to's. Less thans or less than or equal to's. The equal to doesn't matter there. It's the direction of the inequality. And the last thing we got to worry about with inequalities is when we divide by negatives. This is again something we talked about first semester. Something you talked about in Algebra 1. If we have something simple like negative 4x is greater than or equal to 20, okay? If we're trying to solve that for x, we have to divide both sides by negative 4. So then x and then 20 divided by negative 4 is negative 5. But the inequality symbol flips. So when you divide both sides by a negative, the inequality symbol flips around. This is more like how we're going to use this property today. Is if you had something like 5x minus y is greater than 7, okay? So there's our inequality that we're starting with. If we're going to graph that, we'd rather it be in slope-intercept form. So we'd want y to be by itself. So in order to get y by itself, we need to get 5x to the other side. So I'd have negative y is greater than negative 5x plus 7. And I still want to get y by itself, so I'm going to divide both sides by negative 1. So negative 1, negative 1. So that would give me positive y. This would give me positive 5x. And this would give me negative 7, so minus 7. But that inequality symbol needs to flip around. So now y is less than 5x minus 7. And this has nothing to do with why the inequality symbol flips around, just that purely the fact that it does need to. Okay? The y has a whole different bit. If you really are curious about it, you need to talk to me about on your own time. You should have learned that a while ago. Okay. So those are things we just got to watch out for when we're graphing an inequality. We're going to start off with a really basic one, graphing a system of two equations. And we're going to work on making it a little bit more complex. It's still just two equations. Then on the back, we're going to look at, hey, what if there's 3 equations? What if there's 4 equations? Okay. And then we're going to be looking at how do we know, where the solutions are. So we'll be checking some points. Okay. So you guys speak up if something's not making sense. Again, really should have a straight edge if you don't have one yet. So when I want to graph a line, I either want it to be, just x equals a y equals or in slope-intercept form. Okay. And so I look at this first one, and if I pretend that that's an equal sign instead of an inequality, just that that's x equals negative 3, and just like we talked about a little while ago, that's going to be a vertical line through negative 3. Well, the next thing I need to think about is what type of line is that besides being vertical? Is it solid or is it dashed? Okay. Well, it's equal to, so that means it's going to be a solid line through negative 3. Right, Jared? Okay. So I'm going to go and draw a solid line, vertical line through negative 3. So I was talking about what type of line it is, as far as like being vertical, horizontal, diagonal, and then again, what type of line is it as far as being solid versus dashed. Okay. And I go to look at the next one. Oops. So this one's in slope-intercept form, y equals mx plus b. So I have my y-intercept at 4. And the slope is 2 over 3, rise 2, run 3, rise 2 to the right 3, rise 2 to the right 3, rise 2 to the right 3. I would do at least 3, if not 4 points if I were you guys when you're plotting those out. You can, and I like to usually do the whole thing. So I'm going to go down 2 and to the left 3, down 2, left 3, down 2, left 3. But if I was you guys, I do at least 3 or 4 points. I usually like to do as many as I possibly can to get the line kind of mapped out. So now I know where the line is going to be, and then I go back and say, well, what type of line are you going to be? And that's not equal to, so that's going to be a dashed line. So I'm going to draw a dashed line for this one, not a solid line. Make sure you're stopping and thinking about that before you draw it, because if you draw a solid one, you have to go and try and fix it. It's a pain in the butt. So don't rush through this, even though it seems easy. And I do need you guys drawing the lines all the way across the coordinate plane. They can't be short, so they need to be all the way across, however they're going. Okay. So I would always get both lines, or all 3 lines, or all 4 lines drawn before I worry about the shading. So get them all drawn first, and then go back and say, well, what about the shading now? Okay. So you're looking, this is just a reading thing, because you say, well, that says x is greater than. So I don't need to read any more than that. I just need to know that x is greater than. And greater would be to the right. What's up, Sam?
I you said it, but how do you know where to start your like dash? Like I know it's up 2 over 3, but where do you start?
The y-intercept. Well, yeah, the point on the y-axis. So when you guys are shading, do not shade darkly initially. Okay, you're gonna shade very, very lightly. Okay, so you're gonna see me just a few lines going across. You want to do this as light as possible, where you can see it. But if you make a mistake, that you don't have to erase a whole bunch of dark shading that you messed up. Okay, so you do not want to shade with any darkness at all beyond the minimal amount. Initially, we'll go in and we'll darken it later once we know for sure that we did it right. Okay, we'll talk about how to figure that out later. We start okay there, so that's greater than -3, so to the right. The next one, y is less than. That's all I need to know. Y is less than. Less than means below the line, so I'm shading this way. I don't need to know less than what, I just need to know it says less than. So I'm shading there. So we think, right, I'm going to shade it in. I don't want you guys doing this yet. Think that this space right here is where our solution should be. That's where they're both shaded, right? This space over here, just one of them shaded. This space over here, just one shaded. This space over here, none of them are shaded. So the answers are supposed to be in this space, I think. I'm not sure yet. We haven't checked. Okay. So now we started that how do we check process. Okay? And for me, the first thing I'm asking you guys to do is something very specific, because I want to clear up a couple things. But for the most part, it's going to be you guys are going to be picking a point on your own and showing if it works or not. Okay. Here I'm asking you guys about these specific points because I want to talk about something else with you guys. So anything about the graphing of the lines, the shading, deciding which line, what type of line to draw, any of that stuff you guys want me to clarify before we move on to the checking stuff? Good, Jubal. Good, Addison. Thanks, Kyle.
If the y, if the less than sign, if that was a greater than sign, would it be on the top side?
Yeah, it would have been
right there.
Yep. So then we would have been looking at this space for both, right? Okay, so is 0, 4 a solution to the system? So where is 0, 4? It's right here on that line, right? Is that a solution to the system? So the x value is 0, the y value is 4. That first inequality says x is greater than or equal to negative 3. Well, so I plug in x. 0 is greater than or equal to negative 3. I can't plug in the 4 because there's no y spot. So is 0 greater than or equal to negative 3? Sure is. Yep. So works there. Then I plug that point into the other equation. So so 4 is less than 2/3 times x, which is 0, plus 4. And we got a little bit of math to do now. Of course, 0 times anything is 0. So I get, and then 0 plus 4 is 4. So is 4 less than 4? No. So that point is not a solution to the system. So it has to work for both in order to be a solution to the system. It worked for one, not the other. So why didn't that point work? Okay. That point never had a chance of working because it was on the dashed line. And the points on the dashed line are never going to be solutions to the system because they aren't even solutions to the line that they're on. Okay? Remember, we're saying that those points, what works for this is purely the things that are greater than that or less than that line. Okay? So kind of the same way that, if I said, hey, you have to be older than 17 to go into this rated R movie or whatever, you're like, but I'm 17. I'm like, sucks to be you, you have to be over 17. Okay? So being on that line, you are not a solution to this inequality. So there's no way that was going to be a solution to the system. So if you're on a dashed line, there's no chance of being a solution to the system. Why is that rotating? Okay. What about negative 3, negative 2, which is here? Okay, so another point on the other line. So negative 3, negative 2. So my x value is negative 3. So I get negative 3 is greater than or equal to negative 3. Well, negative 3 is equal to negative 3, so that's true. And then y, so which is negative 2, is less than 2/3 times negative 3, which is x, plus 4. Then we got a little bit of math to do over here. This works. Remember that 3 is dividing. So negative 3 divided by 3 is negative 1 times 2. So negative 3 divided by 3, negative 1 times 2 is negative 2. This is equal to negative 2. Plus 4, negative 2 plus 4 is 2. Negative 2 is less than 2. So it works. So yes, it is a solution. So that first point, 0, 4, was on the dashed line. It had no chance of being a solution to that system because it's on a dashed line. The second point is on a solid line. That means it has a chance of being a solution. It does not mean it is a solution. Okay? I could have picked a point up here. That point would not be a solution to this system because it's not an answer to the blue one. So only points that are on this line that are also below this line are solutions. So if you're on a solid line, you have a chance of being a solution. You are not necessarily a solution. These are not. If you're on a dashed line, you have no chance of being a solution. So just kind of watching out for those things, okay?
Have you grabbed that when you stop the line? Have you grabbed that when you just stop the line at that?
Oh.
So like right at where it's happening.
So Aiden's asking, like, could we just stop the graph at this point? Well, we got to watch out there is you don't know which side of the graph you're looking at. First, the first line, we have to graph the whole one because we don't know where they're going to cross. And the second one, we don't know which side of the line we need to look at because we don't know if it's the left side or the right side yet because we haven't done the shading yet. So I might as well just do the whole line and then worry about that later. So yeah, I wouldn't try to short the graphs at all. Okay. All right, so I was just me trying to show you guys what's up with those lines because there's usually a lot of confusion about the lines with students. So I'm trying to just kind of hit that right there real quick to help you guys out with that. But Mostly it's going to be you guys picking points and just checking. This is how you're going to check your shading. Is this actually the correct place to shade? And once we know it is, we can shade it a little bit darker and actually say, hey, here are my answers. Okay? So you get to pick any point and show it's a system. So what you want to do is pick a point that's in this space. Do not pick a point that's on the lines for this very reason, that they don't always work. You need to pick a point that's in the space here. So since we get to pick any point we want, and we always like to do things the absolute easiest way possible, what would be the easiest point to pick that's in this space? Yeah, the origin. Okay. So let's pick that point that's going to have the easiest math, right? 0, 0 should be easiest. So if you have that opportunity, pick the origin. But really, it doesn't matter what point you guys pick. You just pick any point in this space, and we're going to check it. Okay? But if there's something about how can I make the math easy, let's do it this way. Okay? But so pick any point in that space. Let's check it. So x is 0. So 0 is greater than or equal to -3. Sure is. Y is 0, less than 2/3 times 0 plus 4. 0 plus 4, so 4. 4 is greater, or 0 is less than 4. Sure is. So now that we know that this point works for both inequalities, now we can shade this a little bit darker. And again, don't shade it like you're trying to color in the night sky or something like that, okay? Just shade it lightly, still, but darker, like you're kind of, okay, yeah, this is it, okay? But it's this, trapezoidal space here is where the solutions are. Okay, and the point is that any point within that space, and then off to the right forever and off down forever would be solutions to this. Okay? Let's pick a point and show that it's not a solution. So where can we pick points from that aren't solutions? So we have 3 spaces here. Points up here shouldn't work for both. Points up here shouldn't work for both. Points up here, over here shouldn't work for both. So even if they work for one, that's not a solution to this system. So we can pick any point in one of these 3 spaces. Sam, what point do you want to pick? 0, 6, 0, 6. All right, so 0, 6 up there. So x is 0, 0 is greater than or equal to -3, sure is. 6 is less than 2/3 times 0 plus 4. 0 plus 4 is 4. 6 is not less than 4. So there. As soon as it fails one, it fails the system. It has to pass both in order to pass the system. If it fails one or both, it fails the system. So this is the process, guys. There's nothing else like different about that besides just the complexity of the equations. Like here we have some work to do, but then we're going to graph them. We're going to check to see if our answers are right. None of that stuff is going to change. Right? Just practicing what type of line do I use, which way do I shade. Okay. But there's nothing new for me to teach you beyond that. The rest is just practice. Is there any part of this you guys want me to make sure I hit a little bit harder next time? Clarify on? Sophia, how you doing? June, how you doing? Raylan, how you doing? Dion? Okay. All right. Thanks, Sophia. All right, so looking at these 2 inequalities here, they're not in the right form. They're not in slope-intercept form, so that's the first thing we want to do is just get them into slope-intercept form. So I'm going to bring that guy down, do a little bit of work. So 2x plus y is greater than or equal to 5. Get y by itself, so I'm going to subtract 2x. So y is greater than or equal to -2x plus 5. Okay. I like to do all the work before I go and do the graphing. It's just really personal choice. So I'm going to get this one also into slope-intercept form before I go and graph. So I can stay over here in that same type of thinking for a minute. I want to get y by itself. So first thing I'm going to do is subtract x. Don't lose that negative on the 4. Negative 4y is less than negative x minus 8. Now I want to get rid of that negative 4 by dividing. So I'm divided by negative 4, divided by negative 4, divided by negative 4. So y, I have negative 1 divided by negative 4. That's negative 1/4. Kick that off to the side. 1 over 4. Put the x next to it so it looks like a slope. I have negative 8 divided by negative 4, which is positive 2 plus 2. So 1/4 x plus 2. But I just divided by a negative, so my inequality flips around. Now it says y is greater than 1/4 x plus 2. Super easy to forget that. Of course, that's going to make a big difference in your shading, so you got to make sure that's flipped around right. Any questions about getting the inequalities into slope-intercept form? Let me just go graphing. So that red one starts at 5 on the y-axis. Slope is negative 2. Down 2, right 1. Down 2, right 1. Make sure you're moving to the right, not to the left. Down 2, right. Down 2, right. Your slope, your line should be going down and right. And then up and left, up and left, up and left. Only one of the numbers is negative, not both. And then I look back. Now I have it mapped out. I say, is that a solid line or a dashed line? Solid line. So equals 2 means solid, right, Sam? So now I'm going to go and draw a solid line on that. Next one starts at 2 on the y-axis. Slope is 1 over 4. Up 1, right 4. Up 1, right 4. Or down 1, left 4. Make them both negative for positive. Down, so it should be going up and to the right. Aiden, is that a solid or dashed? Yep. No, not equal to, so that's a dash. If it's equal to, it's solid. If it's not equal to, it's a dash. Doesn't matter if it's less than or greater than, just if it's equal to or not. What's up, Aiden?
I always thought that it would be dash, or like, could it center with the hollow itself? I thought it would be dash for the 2, kind of center that line is. 3 at least.
So generally with math, when we say like a dash lines, like when we're drawing our asymptotes, we're drawing the axis of symmetry, dash lines represent things that aren't there. So these points that we're drawing aren't actually solutions to that inequality. The points that we draw, the solid line that's made up completely of points, are things that are actually mathematically there. The dashed line is purely for our eyes. It's not mathematically part of the system. So, yeah. For me, with the dots, I always thought of the hollow dot kind of like a little shield around the number, so I couldn't actually get to it. I could just get really close to it. And then if I wanted to grab the number and actually have it be part of my answers, then I had to close out. That's how I always went. So. All right, so there's our lines drawn. Then we have to go back and say, well, what about my shading? Okay, so we go back and we look at the inequality. You have to read this, guys. All right, stop and read. Y is greater. And as soon as you say greater, you're done. That's all that matters, because greater means above. Okay, so I go and I shade above. So I'm going to show you a different way you can do this. So one, I get to say, oh, I'm going to shade above. Lightly shade this way, right? Very lightly, just in case I made a mistake. Another way you can do it, sometimes I just draw little arrows heading off in that direction. There's above. There's another option. So if you don't want to shade a bunch, then maybe you have to erase a bunch. Okay, so just drawing a couple arrows that are saying, I'm shading that way. Okay, I'll show you what that looks like in a sec. And then the next one says y is greater. So I go to that green line and I go above it. So again, I could do lines, or I could do a couple of arrows and say, well, where do these arrows kind of head off together, right? We can see in that top right space, they're kind of heading in the same direction. So if I want to do arrows, there's a way. If you want to do the hash marks, shading, you can do that. Okay. So just a couple of options as far as the shading goes, that where you're not doing a whole bunch of shading initially until you're sure that you actually did it the right direction. You do not want to try to erase shading that you've made really dark. Okay. I think it's a little bit easier for you guys to see if I do it this way. So there we can see where they're cross-hatching. There's our double shaded region, we think. Now we're going to go and check that, make sure we actually did it right. So pick a point, show it's a solution. Caleb, what's a point up here you want to use?
3, 4.
3, 4. That's not 3, 4. Okay, 3, 4. Remember, don't pick a point on the lines. Either line, don't do that when you're checking your shading. It has a chance of really screwing things up if you do that. And then when you go to check, you have to use the original equations or the original inequalities. You cannot use these things over here that you made, because if you made a mistake from here to here and you check it in your wrong inequality, it's not going to show up as being wrong. You have to go back and say, does it satisfy the original problem? So that's always been a rule for us when we go to check, is you use the originals and you do not solve while you're doing it. 2 times 3 plus 4 is supposed to be greater than or equal to 5. Well, that's 6 plus 4, which is 10. 10 is greater than or equal to 5. Check. 3 minus 4 times 4 is less than -8. Yeah, 3 minus 16 is -13. -13 is less than -8. Check. So now that we know that, we go and shade this a little bit more. So there's all my solutions. This next question I'm asking you guys, again, I'm just kind of poking at something, trying to help you guys make sure you understand this. I want you guys to pick a point that's on one of the lines. Pick a point on one of the lines and show that it's not a solution to the system. So where can we find a point that's on a line that's also not a solution? Where can we find a point that's on one of the lines but also not a solution? So if it's on the dash line, what'd you say?
Yeah.
Okay. So if it's on the dash line, it has no chance of being a solution. Right? That's kind of the idea here. Right? So if you pick any point on that dash line, so there's one like -4, 1, right? For 0, 2, there's, right? So any point on that dash line will not be a solution. No chance. Where could I find a point on the solid line that's not a solution? Where's a point that's on the solid line that's not a solution?
Oh, right below.
Yeah. Yeah. Any point on this part of the solid line will not be a solution to the system because it's not a solution to both. So you could pick any, like 2, 1, 3, 4, -3. Okay. So you're right, Kyle. Okay. So you can pick any of those points over here. You pick 2, 1 there, right? Those would also work, okay? Or also not work, right? So if I did 2, 1, you guys can pick whatever you want, okay? I'm going to do 2, 1. So 2 times 2 plus 1 is greater than or equal to 5. Well, that's 4 plus 1, which is 5. So 5 is greater than or equal to 5. Check. So it solves that part, or satisfies that part. 2 minus 4 times 1 is less than 8. 2 minus 4 is negative 2. Negative 2 is not less than negative 8. So as soon as it fails 1, it fails the system. So you can be on a line and not be a solution. So just again, trying to point that out to you guys. So it's generally one of the things that confuses students. So I want to kind of cover it a couple times. But when you're checking your shading, do not ever pick a point on a line. It's not a good idea no matter what. Okay? Always pick a point in the space. All right. Anything there you guys want to talk about? Make sure you guys, the next one's like the graphing. We may not do the checks as much just because of where time is, but I want you guys to see the graphs as they get just a little bit more complex. So on the third example here, we have 3 lines we're going to draw. As I'm looking at that, I'm just kind of making note of what I have and what work I need to do first, right? Like I look at this first inequality, I'm like, oh, that one's ready to go. I don't need to worry about it. And I look at that last one, like, oh, it's ready to go. I don't need to worry about doing anything. But then I look at that middle one, I'm like, oh, okay, I got a little work I need to do first. So I'm just going to go ahead and do that work first. Again, this is just personal choice. I want to get that out of the way before I go to all, and I can go to all the graphing at the same time. So I need to get y by itself. So I'm going to subtract that 2x to the right. So 3y is less than or equal to negative 2x plus 6. And I'm going to divide everything by 3. So y is less than or equal to, so 2/3 does not reduce. So I'm going to kick that fraction just to the side. So negative 2/3 x, and then 6 divided by 3 is 2. And I do not flip the symbol because I did not divide by a negative. I divided by positive 3, so that stays put. Now I'm going to go back and look at my system and say, okay, what am I going to draw? So x lines are always vertical, and then I see a equals to, so that's a solid. So I'm going to draw a solid vertical line through 2. So I can make sense of that real quick with those x ones and y ones. Solid vertical line through 2. And then we go down to the bottom one just because it's the next easiest one. Y lines are always horizontal, and that's an equal to it, so it's solid. So I have a solid horizontal line through negative 4. Then I'll worry about that purple one. It's going to start at 2 on the y-axis. The slope is negative 2 over 3, so down 2, right 3, down 2, right 3, down 2, right 3. Or I can go up 2, left 3, up 2, left 3, up 2, left 3. So make sure that's going down from left to right. It's a negative slope, better be going down from left to right. And that's also an equal to, so that's going to be a solid line. Once I have all 3 lines drawn, then I go worry about shading. Don't shade until you've got your lines all drawn. Just a bad idea. And then I'm going to shade very lightly so that first one says x is, what's that? X is what? X is what? Read it. Greater. Yeah, that's all you need to say. X is great. Boom. Done. Now what's that mean? Shading to the right. Okay. And then the blue one, again, that one's just easier. So y is also greater than. So now we're shading above that blue line. Okay, so we start to see where they're crossing over there on the rightish. And then the purple one, y is less than, so Y is less than, so I'm going to shade below, so I'm below the purple line. You know, why you guys want to do this as lightly as possible, right? See how much stuff is going on here. Okay? So this is why the arrows sometimes are nice, because you don't have so much stuff. Because you mess up one of those, you're like, ah, crap. You have to erase, you're going to erase a bunch of stuff. So where do they all cross? Should be seeing this triangle space here. We think that's where it's going to be, right? We don't ever want to shade it darker until we know for sure with a check. So, is that not going away? There we go. So I picked some point in there, probably like 3, -1 or something. That's not down there. You know, like 4, -2 would be a pretty good point to check. All right, let's go. Yeah, so that's where I'm not going to do the check. Well, yeah, I'll do one of them. 4, -2. Again, you have the x value on that first one. So x is 4, so 4 is greater than 2. Sure is. 2 times 4 plus 3 times -2. It's supposed to be less than or equal to 6. 2 times 4 is 8. Plus -6. 8 minus 6 is 2. 2 is less than or equal to 6. And 4, so our y value is -2. It's greater than or equal to -4. Check. So yeah, it was that little triangular space right in here. That's where our solutions are. I'm going to skip past that next check just because we're getting short on time. And so when you guys do the stuff on Monday that we're going to do, it's going to be more similar to like a problem like 3 or 4 where there's going to be lots of lines, not just 2. Linear programming represents usually like some sort of restrictions that you have on like manufacturing. I have to make more than this, but I can only, I can't make more than this other amount, and I have to spend so much time doing this. Like there's all these restrictions, and they create basically a little box of where possible things could happen. So again, what I would look at if it was me is just, okay, can I draw this line right now? Right, that first one. Oh, that's a vertical solid line through 0. Oh yeah, I can draw that right now. On the next one, horizontal solid line through 0. The next one. So horizontal line solid through 6. And last one. So that's not solved for yet, so I need to divide by -4, divide by -4, divide by -4. Since I'm dividing by negative, it's going to flip my inequality around. So y is less than. 5 and 4 don't reduce. That's just going to say -5/4. Kick that off to the side. -5/4 x. -32 divided by -4 is +8. So then I'm going to graph that guy. That's also a solid line. So we go up to 8 on the y-axis, down 5, left 4, down 5, left 4. Should only be able to do that twice before we run out of space. And that's a solid line. So this may be when you look at a system like this, when there's so many lines and you probably don't want to do all that, even the light shading. This might be where the arrow method becomes a little bit more necessary or nicer, because you're not drawing so much stuff all over your graph. So if I just look at a couple arrows to see like, hey, where's all this stuff headed? Like that purple one says y is less than, so it's kind of heading off in this direction. The red one, it says y is less than, so it's heading down. The green one says y is greater than, so that's heading up, so it's between the green and the red. And the blue says x is greater, that means it's to the right of the blue one. So what space, do we capture there? Yeah, not actually triangle, but yep, trapezoid. So it looks like this space here should be where the answers are. So we would grab a point in there, maybe like 2, 3 or 2, 2 or something like that. As checking that point. So check 2, 2. Never check a point on the lines. Always check a point in the space. And you just do it the same way. It will work, of course. So that's the idea behind all this stuff, guys. Okay? The worst thing you guys can do is rush through stuff and make silly mistakes, because those silly mistakes can get just really annoying to fix because you have to erase a whole bunch of stuff. So just go slow. You're just graphing lines. Something you guys have done hundreds of times before. Okay? Just go slow. Make sure you're doing your dashes versus your solids. Watch the shading directions. Really read to yourself, guys. Say y is less than, x is greater than. Say it.